So in this question, they ask us to use a logistic model with the same coefficients as in question 2 to find the maximum growth rate, which is the rate of change of the number of Snapchat users from November 2011 until January 2017. So here, we're actually asked to use a logistic model, but they're asking for what the, not the number of users, but the when and the maximum growth rate happened between the start of Snapchat in around November 2011 and January 2017. So whenever you're asked to figure out what the maximum or absolute minimum of a function is, this is an absolute maximum or min problem. So the first thing we need to know is we need to know what function are we trying to maximize. So they say we have a logistic model. So we have a model that looks like Q of t is equal to b divided by 1 plus a e to the negative b k t. Now I should mention here, we know what a, b, and k are. We could, in principle, plug all of those numbers in if we wanted to. But I'm just going to leave them as a, b, and k, just because it makes the solution a little bit less messy. The only real variable in this model is t, is time. The rest of the letters are spoken for. We have values for a, b, and k. So you can consider them as already fixed. We don't have to worry about them, and we're going to take the derivatives with respect to t. However, this is not what we're supposed to be maximizing. They're not looking for when there is a maximum number of users. They're looking for maximum growth. When did the maximum growth happen? So in that case, they're looking for the maximum rate of change. So we're going to find the rate of change of the number of users. We're going to take the derivative because the derivative is rate of change. And using the quotient rule and a little bit of a chain rule, what you actually find is that the derivative of q is actually a b squared times k e to the negative b k t divided by 1 plus a e to the negative b k t squared. Okay, so that was just using a product rule, or sorry, a quotient rule and maybe a little bit of chain rule to arrive at this. Okay, so now that we have the derivative, so this is the rate of change of users. We're going to give that a name. We're going to call it growth. Okay, so this is the function that we're trying to maximize. We're trying to maximize the growth function, which is this one that we just got here. So whenever you're dealing with an absolute maximum problem or an absolute minimum problem, the only places that absolute maximums and minimums can happen are at the critical points as well as the endpoints. So the endpoints for us, so let's just write those down quickly. For us, the endpoints are month equals 0, so t equals 0, so when Snapchat started, and t equals 62, which is January 2017. So these are our endpoints, and so we're going to actually evaluate our growth at these two endpoints as part of our question. But before that, we're going to find the critical points, because again, the only places that the maximums or minimums can happen are at the endpoints or at the critical points. So let's find the critical points. Critical points happen wherever the derivative is 0. The derivative of the function you're wondering about is 0 or doesn't exist. So we don't have any problems with things not existing because you can see from the, well, first we need to take the derivative. So let's calculate what g prime of t is. So again, just using some quotient rule and maybe a little bit of a chain rule, what you can actually calculate is the derivative of our new function g, and what you get out of that is that a b cubed k squared e to the negative b k t times a e to the negative b k t minus 1 all over 1 plus a e to the negative b k t cubed. So again, it looks kind of confusing. It looks like a big mess, but really it's just using some quotient rule and a little bit of chain rule and rearranging some things and simplifying a little bit, and you can actually obtain the derivative of g. So to find the critical points, what we're going to ask ourselves is when is the derivative g prime? When is it 0? and when does it not exist? So it exists all the time, which means you can plug in any t value you want into here. There's no real problems. We have no denominators equaling 0 or anything. So the only critical points will come up when g prime of t equals 0. So let's figure out when g prime of t equals 0. So when does this happen? So let's just take a quick look at g prime of t, which is right here. You notice on the top, of course, this is a fraction. And to make this fraction 0, all we're really concerned about is making sure the numerator is 0. If the numerator is 0, we already talked about the fact that the denominator can never be 0. Whenever the numerator is 0, that's when g prime of t is 0. Whenever the numerator of a fraction is 0, the fraction itself is 0. So we don't really only have to concentrate on what's happening in the numerator. So to figure out when g prime of t equals 0, we just have to make sure that the numerator is 0. Now, if we look at the numerator, we have a whole bunch of constants. Remember, these are numbers. They're given. You know, a is 390, etc., etc., etc. A is a number, b is a number, k is a number. So this little part here, that's all one big number. And then here we have an exponential. And no matter what value of t we put in the exponential, we're just going to get some positive number out of this. So there is no way to make the numerator 0 unless the thing in brackets is actually 0. So that's the only thing that we're actually concerned about. If we can make the thing in brackets 0, then we can make sure that g prime of t is 0, and that's where there will be a critical point. So let's figure out when a e to the negative k b t is minus 1 is equal to 0. Of course, I can put the 1 on the other side and divide by a. And so I get e to the negative k b t is equal to 1 over a. And because I know the rule of exponents, I can also just make that a to the negative 1 if I want. And I do because it'll make things easier for me. So I have that e to the negative kbt has to be equal to a to the negative 1. So I'm trying to figure out what the critical point is. I'm trying to figure out what t value does this. So I would like to solve this equation for t. So what I'm going to do is, because the thing that I'm solving for is in an exponent, I'm going to take the logarithm of both sides. So ln of e to the negative kbt is equal to ln of a inverse. And because I know my rules of lns, I can pull the exponents down. So I have negative kbt ln e is equal to, the negative 1 comes down, I have negative ln a. Now the negatives cancel, so these two things go away. And ln e, of course, this is just 1. So this equals 1. So if I want to solve for t, I just divide ln a by kb. And what I end up with is that t is equal to ln a divided by kb. And I actually have these numbers. I know what k, b, and a are. And so if I actually plug all of that in, what I end up with is that t is approximately 50. So this would say there's a critical point at around the 50th month. So now we have our 3 candidates for when the maximums can happen. They can either happen at our endpoint, which is the 0th month, our other endpoint, which is the 62nd month, or at the critical point, which is the 50th month. So actually, let's figure out what our growth was at all these months. If you plug in 0 into our growth equation up here, if you plug in all the numbers, the a's, the b's, the k's, and the and t equals 0, what you end up finding is that the growth at time equals 0 is 0.119. So that would seem to indicate that there are 0.119 million users per month being added to Snapchat at this point. The endpoint, the other endpoint, the 62nd month, if you plug in 62 for t into g, and you plug in all the other a's and b's and k's, what you figure out is that this is approximately 7.255, I think. So I'll make sure that these are approximate. Which means that in month 62, or January 2017, according to our model, Snapchat is adding about 7.255 million users per month. And then if I plug in my critical point, so what was the growth at time 50? That's approximately 11.692. And so what that means is that in the 50th month, according to our model, Snapchat was adding about 11.692 million users per month. So if you're looking for when was the maximum growth, so the maximum growth occurred at time equals 11.692, and the growth was, sorry, not 11.692. Let me see if I can erase that. This wasn't the time that this happened. The time was actually the 50th month is when this maximum happened. So let me just fix that. The maximum growth happened when it was about the 50th month, and the maximum growth was equal to 11.692 millions of users per month. Actually, million users per month. Okay, so using our model, we can actually figure out when the maximum growth for Snapchat occurred, according to our model.